All right, welcome back. Today's lesson is going to be kind of like a earth science lesson for biology, looking at climate, weather, and life. And it's important because climate and weather do affect life. So I am going to describe the difference between weather and climate, talk about Earth's climate and the average temperature, how are they determined, causes for ocean currents, and then tomorrow's lecture, because I'm only going to cover part one today, will be regional climates and how processes involved in climates can change. So get ready for some flashback from earth science. So climate and weather. Climate are patterns and averages for temperature, precipitation, clouds, wind. It takes many, many years. It does include frequency of extreme weather events, maybe like major floods or major earthquakes. Climates tend to be a little bit more predictable because it's like the average. Okay. Weather, on the other hand, is very short term. Temperature can change from day to day. I mean, we live in Minnesota. We experience this all the time. One day it's 60 degrees and sunny, and the next day we're having a blizzard. Okay. Precipitation, clouds, wind. So weather is day to day. So a question, and what do we got? Well, anyways, both shape populations, communities, and ecosystems. But I'm going to talk about how do climate and weather form and what's the drive-in mechanism for that. Okay. So that didn't go as well as I thought it was going to go. Moving on. So the global climate system is powered by two things. Okay, solar energy or heat, and the second is this unequal distribution of heat between the equator, right here, and the poles. Earth is not, straight up and down. Earth is at a tilt, 23.5 degrees. Because of Earth's tilt, we get unequal distribution of heat. We get seasons, at least we do, because we live in the upper latitudes. Tilt has a lot to do with, like I said, seasons and the climate that we experience. So with latitude and solar energy, most direct sunlight tends to be near the equator, kind of in this tropical region. Okay. And as you move up or down from that tropical region, sunlight that hits Earth gets less direct. It gets more spread out. So you can actually do this with a flashlight. If you have a flashlight and it goes straight up and down, the light is way more concentrated, okay? And it's just because of that you get higher radiation or heat, solar energy. However, if you angle your flashlight, the sunlight rays get spread out. So because you get this spread out, the rays are not as concentrated and you get less solar energy. So up here, this would be like where the flashlight is tilted because that solar radiation gets spread out. And here, solar radiation radiation is more concentrated. Now, because of the tilt, as well as this unequal heating distribution between the equator and the poles, we get wind patterns. Okay, so sunlight hits areas like the equator and kind of this mid-upper latitude or down here where warm air will rise and will cool and it will sink. And then it will rise and cool and sink. We get convection. This is convection, okay? So warm air rises, cools, and sinks. And then not only that, we have to throw in Earth's rotation. So now we have this Coriolis effect and we get different wind patterns. So you get the northwest trade winds, okay? Or the southeast trade winds, or the westerlies. This is the reason why all of our weather comes from the west coast. You want to know what weather is going to hit us the next couple days? Look towards the west coast. So we have the westerlies down here. And then we have the polar easterlies down here. So we get different wind belts that contribute to our weather as well as our climate. But it's all because warm air rises and cool air sinks, also known as convection. So that it produces wind currents, but not only that, it also produces ocean currents. So we have to think about Earth is covered mostly in water. So you see a lot of warm water near the equator, and they can move upwards. Now this diagram is showing cold surface currents. So like at the top, warm surface currents, and then we actually have some deep flow currents which lie down below. But I want to focus in, however, on the Gulf Stream. So here we have warm water that rises and travels up the east coast and across the Atlantic to Great Britain. Okay, Great Britain sits at a higher latitude than we do. So you would think, oh, Great Britain should be colder than us. But that's not the case. Their winters are actually very mild compared to ours. And it's because of the warm water from the Gulf Stream bringing that heat to them. So when you look at average climates, you have to look at winds and you have to look at ocean currents, large bodies of water near them, to figure out their average, if you will, conditions every single day. And so because of wind currents and ocean currents, we produce weather and climate. So here's another diagram showing the Gulf Stream traveling up and then hitting Great Britain and coming back down. Okay, so with solar radiation, we also take a look at the greenhouse effect. We have gases in our atmosphere, mostly CO2 and water vapor, that act like a glass in a glass pane, or the glass that makes up a greenhouse. And what it does is it traps heat. It acts like a blanket, if you will, an insulation. So here's my greenhouse, and if I have energy that enters as light, it's going to warm up the air molecules in here. But air molecules can't travel through glass. So we get this nice convection going on here. Warm air rises and it cools, but inside a greenhouse, it's a lot warmer than outside of a greenhouse. Some energy can escape back through the walls, and we do see this with Earth. Some energy can be lost back to space. However, people think the greenhouse effect is really, really bad. It's actually a good thing. Without the greenhouse effect, our temperature would be more than 30 degrees Celsius cooler. Okay, so without the greenhouse effect, life would not be where it's at right now. So here's a diagram showing sunlight and how, what four things can happen to sunlight as it reaches Earth. So number 1 through 3. Number 1, some solar energy can be reflected. So you can see that it can be reflected. Some can be absorbed by surfaces, like, the ground, the pavement, plants. And some can be radiated as heat. Okay, kind of ricochets off. So you have this nice little bouncing pattern where it hits an air molecule and it bounces off another air molecule and so on and so forth. So it can be just zigzagging across in our atmosphere. And the fourth thing that can happen is that it can be lost to space. So we can actually lose some heat energy. But that's not the case. I mean, it does happen, but the majority of it is down here. Now, greenhouse gases in our atmosphere, like CO2, okay, so one of the reasons why CO2 is, everyone's really worried about our carbon emissions, is that CO2 can stay in our environment for over 100 years before it can escape into space. And so, the more CO2 we put in the air, when our CO2 concentration increases, and now heat gets trapped longer, it doesn't escape to space, thus warming surface temperatures on Earth. I do want to emphasize, however, that the percentage of CO2 in our atmosphere is 0.03%. Okay, 77% is nitrogen, 22% is oxygen, and the remaining 1% is argon and other noble gases and various other gases, but 0.03% for carbon dioxide, CO2. So that's all I want to talk about today with 3.2, looking at weather and climate. So go back to the objectives here. Weather and climate, how do they differ? Short term, long term. How does Earth's climate and average temperature, how do we determine it? Okay, so we would just record things and study patterns of it over time. Causes of the ocean currents has to do with convection, unequal heating of Earth's equator versus the poles. Okay. Tomorrow I'll discuss regional climates as well as climate change.